Alright, let's continue with where we left off yesterday. Okay, shall we run through our answers? Okay, yesterday I got you to go back to give try 8 a try. Okay, after I gave you the plan already. Okay, so I hope that you managed to try it out. Alright, let's look at try 8. Okay, so yesterday we used a diagram that looks something like that. Okay, and then after that this is the center, and our tangent, I imagine it to be this way. Okay, it may not be accurate to what we're going to get. Okay, but essentially it is a tangent at the point -3, 5. Okay, so what we will first do is to define certain things. So let the center be AB and the radius be R. Okay, so we are trying to extract out, okay, and find the coordinates of the center, or maybe the radius as well, okay, from this part of the equation. So x minus a squared plus y minus b squared equals to r squared. Okay, then expand this out so that we can do a comparison. Okay, the general form, in fact, we compare it to the equation of the circle that we are given, such that we can find that -2a equals to 3 and a equals to 3 over -2, so -1.5. Likewise, for our -2b, that is equals to -2. Hence b equals to 1. Okay, if you want, you can go and find out what is the center, what is the radius, but it's not that necessary since we don't really quite need it. Okay, so it's optional that you want to complete this. Okay, so a squared plus b squared minus r squared equals to 0 because there is no constant term given in the equation of the circle. Radius would technically be square root 13 over 2. Am I right at this stage so far? Okay. I just checking because I don't remember why I cancelled something on my phone. Sorry about that. Is it okay so far? Okay. So after we find out the center already, which is actually -1.5 and 1. What we next need to do is to find out the gradient of the radius, because finding the gradient of the radius will then help us to find out the gradient of the tangent. Okay, So the gradient of the radius or to be specific, I'll let it be C, okay, or radius then, since there's no name for negative 3, 5. That would be 1 minus 5 over negative 1.5 plus 3. And that's negative 8 over 3. Okay. Then our gradient of tangent will be negative 1 divided by negative 8 over 3. That gives us 3 over 8. Okay. So now that we have the gradient of the tangent already, we do have the point on the line, that means the tangent, so we can solve, find the equation, okay, of the tangent. That will be y equals to 3 over 8x plus c at the point negative 3, 5. And we have y equals to 3 over 8x plus 6 and 1 over 8. You may leave your answer as 8y equals to 3x plus 49. That's possible as well. Are we all able to get this answer? Shall we move on to try 9? Okay, I want you to do try 9 part I on your own. Okay, because we have already done something similar before already. Okay, so given 2 points on the circle that forms the diameter, we want to find the equation of that circle. So imagine it out. Y at 1, negative 2, maybe around here, negative 5, 8. You can find the radius, you can find the center using midpoint formula. Right? Give you about 5 minutes to work on that. on the whiteboard already. Give it another 3 minutes. Your radius will come out to be a third. Alright? So leave it exact because in your equation of a circle, eventually it will be r squared. So it should be a nice integer. Okay? It shouldn't be a decimal. answers. Right, I walked around, okay, I saw that at the beginning, most of you are either stuck in recalling what is the formula for finding midpoint, otherwise the formula for length of line segment. Okay, so do try to recall them. Okay, to remember this formula, otherwise you'll be stuck in such questions. Okay, then after that, I looked at how you go about calculating. Okay, in finding the radius, right, I think we have two camps in terms of the answers. Some of you have already found the center of the circle, so you know how to use the center of the circle with either the coordinates of P or with Q to find out what is the radius. Alternatively, we have another camp of students, okay, who want to find the length of PQ, which is the diameter. Then you divide it by 2, okay, which will lead to something like that. Okay, so half times all this, then we get half times square root 136. So this is the part where we need to know how to simplify our surds, which is what we covered last year. Okay, so 136 is divisible by 4. So in fact, it is 4 times 34. Okay, so square root of 4, that is 2. That means that it will be 2 over 2 square root 34. In other words, square root 34. Okay, I'm just explicitly writing down all the steps. Okay, so that it helps us in recalling our surds. Okay, so then also there are people who directly press entirely into calculator, and then you realize the answer is a decimal. So when you realize it's a decimal, okay, you might need to go back or maybe just press the square, okay, the square button, okay, to know what is the number inside the square root itself, okay, and that will be 34. So keep in mind that the radius is actually square root 34. We need our answers to be exact because later on for equation of circle, fill that up, it will be r squared, so that means square root 34 squared. Naturally, it should be an integer. Okay? So there shouldn't be a reason why your equation of a circle ends off to be a decimal unless, okay, the radius, the coordinates they give to you is actually decimal value, which is very unlikely. Okay, so far they always give the same thing. Okay, in fact, my student who was doing 10-year series last year, he noticed that all the circle questions have the same radius one. I think it's always 5. Then all the center all the same or something like that. Okay, there's a pattern he realized after doing 10-year series for so many times. Okay, so maybe you also realize that pattern. But of course, let's not rely on their pattern. May not always be the same answer. Okay, so yeah. Right, now let's move on to part 2. Okay, it says that the line 3x minus 5y equals to 13 meets the circle at Q. Okay, so it only says meet. Okay, at this point we don't know how it meets. Maybe it can 2 points or 1 point. That's why the question later on asks, explain why this line is the tangent to the circle at Q. Okay, so for us to know that it is a tangent, it must satisfy one property. Okay, so there's a line over here. Let's write that line. Okay, if there's a line that passes through and if that is a tangent, okay, the property that it must satisfy will be that it must be perpendicular to the radius. In this case, at Q itself, the radius is also the diameter. Okay, in fact, a part of the diameter. Okay, so therefore, the tangent is also perpendicular to the diameter. Okay, so if this line is a tangent, it must satisfy that property of being perpendicular to the radius or the diameter. Okay, so we just have to check for perpendicularity. Okay, how do we check for perpendicularity? We check that the product of gradients equals to -1. Okay, so part 2. Okay, we find out what is the gradient of the line that we are given. Okay, and then we let center be C for convenient naming. Then we can find the gradient gradient of the radius, or you can find the gradient of the diameter. They are all the same. Okay, and we find that it is negative 5/3. Sorry, so this down here, gradient of tangent and gradient of line. It's not yet tangent now, we haven't proved it yet. It's 3/5. Okay, it is critical that we write down 3/5 times negative 5/3 equals to negative 1 to show that the product of gradients equals to negative 1. Okay, so we now can conclude that since the product of gradients of the radius and the line is negative 1. Okay, the radius and the line are perpendicular to each other. Okay, hence it satisfies tangent perpendicular radius property, and 3x minus 5y equals 13 is a tangent to the circle. Thank you. Okay, fairly long answer. Yes, actually. Right, are we done copying? Okay. I just want to bring us through how to go about crafting this explanation, okay? Okay, so you see, right? What we did is that we're trying to make use of the tangent perpendicular radius property, okay, in order to prove whether it is a line actually a tangent or not. Okay, so in order to prove this is satisfied, we make use of the product of gradients, okay, to show that it's equals to -1. Alright, so there is that link, okay, but in between there are certain things that needs to be connected. Okay, so what we did was, this is the evidence that we have. Okay, this is the evidence that we have done, right, in order to prove that. But you need to be able to interpret this one. Okay, okay, when the product of the gradients is equal to -1. So you need to provide the so what. Okay, and that is over here where you interpret that calculation. Okay, so you need to interpret the calculation. You cannot just tell me that because the product is -1 and then jump to tangent perpendicular radius, because that is not the direct link one. Tangent perpendicular radius property doesn't tell you that product is -1. Okay, product -1, it is about two lines being perpendicular to each other. So you need to provide that link. Okay, so do that interpretation. Okay, then after that, you say that it now satisfies the tangent perpendicular to radius property. Therefore, okay, the line is actually tangent to the circle. Okay, usually the conclusion, just copy the phrasing, okay, in the question. Okay, the tangent, this line is a tangent to the circle. Just copy. Okay, I just repeat only. Alright? Okay, so you need to really have the evidence, interpret the evidence. Okay, the interpretation part is very important. Alright? Okay, so just now Ashley was actually proposing, okay, she proposed an alternative method which is actually the same thing. What she did was that she found a gradient, okay, and then she went to find what is the perpendicular line, okay, that passes through the tangent. Let me draw a diagram. Okay, so having a circle, tangent over here. Okay, she find out what is the gradient of that line already. Find out what is the perpendicular gradient, okay, the gradient of the perpendicular line. See if this line passes through the center or not. If it passes through, then yes, okay, it satisfies this. Okay, it's just another way of thinking to check whether the line passes through the center. Alright, so I leave it to you. If you want to, you can check in with her. Okay, I think that at this moment, okay, I think this should be sufficient already. Okay? Questions? Alright, let's move on. Last question for circles. Okay, let's look at try 10. Okay, the question, one statement only, right, doesn't provide you with much information, but the working is going to be slightly long. They want you to find the equations of the tangents to this circle, which are perpendicular to the line x plus y equals to 1. Okay, at this stage, since this is the last question already, I want all of us, based on this question, draw a suitable diagram. I'm only going to draw a circle for you. Okay, give you about 2 minutes. Think about how a diagram, okay, how the diagram could look like, okay, for this question. That will help you out. Okay, before I draw my own diagram to show you. Okay, don't go and copy from the same similar question from the word example. Figure something out on your own. whole purpose is that you need to be independent to know how to draw a suitable diagram, yeah? Okay, so let's see how your diagram compares to mine. Okay, so which are perpendicular to the line x plus y equals to 1. So this is a critical information first. Okay, because we need this one before we can decide how our tangent will probably look like. Okay, so with x plus y equals to 1, we know that means that y equals to negative x plus 1. Okay, so that means this line itself is downward sloping. The question did not mention whether this line intersects with the circle or not. Okay, so the line will happily be outside of the circle. Okay, so there's really not much information given until you go and calculate lah, but that's not the point here. Okay, we just draw a rough diagram. So I'm just going to draw one outside of the circle. Okay, because the more lines I have inside the circle, the more confusing my circle is going to look like. Right? So I just draw one outside, downward sloping. Okay. Then after that, the question says that the tangents are perpendicular to it. So we want lines that are perpendicular, okay, to your x plus y equals to 1. So this one is x plus y equals to 1. And then tangent to the circle. So something like that. Okay? I hope that you get something similar. Maybe your orientation might not be the same. Maybe your line is up on top here, perfectly fine as well. Okay, maybe this line is actually cutting through the circle, also okay. Right? But something like this will do. Okay, so we got two tangents. Okay, a hint given in the question is that we're looking for equations of tangents. Okay, so you should know that you are looking for more than one tangents. Okay. So since tangent itself is a line, it is a straight line, we make use of y equals to mx plus c, okay, to figure out what is the equation of that line. That means that I need to know the gradient, I need to know the coordinates, okay, on that point itself. Alright? So for the gradient, we can do that by making use of x plus y equals to 1. So this gradient is negative 1, which means that our tangent will be equals to 1 for its gradient. Okay? So the equations of our tangent at this juncture y equals to mx plus c, gradient is 1, so x plus c. I want to grammatically correct. So equation of tangent is, okay, we just go by one first. Okay, so now with the equation of the tangent, we know that our tangent will pass through the circle, right? Okay, that means it is intersecting the circle. Okay, and with any form of intersection, we do simultaneous equation solving, right? So this being equation 1, the next equation will be the equation of the circle. So that's equation 2. Okay? Then x we sub in 1 into 2. Hence we have x squared plus x plus c squared minus 4 equals to 0. we arrive at this? Okay, at this juncture, right? Okay, at this juncture, we need to recognize that this is a quadratic equation, okay, in variable x. X is a variable, c is a number that we're trying to find. Okay, so all these are just numbers that we're trying to figure out. Okay, it is a quadratic equation plus x squared. Okay, now how to solve? Okay, because we have c, we have x, in fact, it doesn't seem like there's any way out. Okay, we need to recognize that this is after all about a tangent and a circle. Tangent, okay, meets a curve at one point only. Right? This brings us way back to the first two chapters that you learned in Set 3. Okay, your discriminant. Okay, so I can hear the dread. Okay, so if you recall from your discriminant chapter, okay, all your b squared minus 4ac, okay, touch at one point, okay, means that your discriminant equals to what? Equals 0, huh? Okay, if more than one point, that means 2 points, what would it be? It will be more than 0, huh? Okay. Doesn't touch at all, will be less than 0. Right, so just a quick recap. Okay? So that means that in this case, touch one point only, your tangent discriminant equals to 0. So your b value is 2c. Okay, a is 2 plus c squared minus 4 is your c. So maybe I'll write it clearly. That since tangent meets circle at only one point, okay, there's only one real root. So b squared minus 4ac equals to 0. Okay. This statement here is not necessary in your working. I'm just writing it here for your note-taking purposes. So it's not needed in working. Unless the question asks you to explain. Okay. So then we solve this. 4c squared minus 8c squared minus 4. So that's how we go about finding out the value of c. Okay? Because that's what we need for the equation of a tangent. Okay? Our value of c has two values, plus minus square root 8. Since we already know certs, we need to simplify it to square root 2. Because 8 is 4 times 2, 4 can bring out become 2. So this concludes that equations of tangents are y equals to x plus 2 square root 2 and minus 2 square root 2. homework. I write here, okay? Exercise 8.1. Question 7, 11A, 13, 23, and 26. Okay, we now have 10 minutes left for our lesson. Okay, I don't think I want to start on differentiation, not that meaningful. So I'll leave it to you, okay, for the rest of this time now. Okay, you can start doing this homework question. Okay, if you have any problems that you're still facing with circles, I'll come around to help you. Okay, basically that's all for today. Alright? Okay, this homework due on Monday, can? Okay, due on Monday, alright? I really need it to be submitted by Monday because I need the weekday next week to go and mark your homework. Otherwise, this AMATS WA, I cannot return it in time. Okay, so do try to give it to me on time, alright? But of course, if you're dying at home already, then tell me lah, okay? I don't want you end up late to class. Okay, so you mind.